This is a May, June 2023, 41 variant. Part A, 3A. State the reason why two objects that are at the same temperature are described as being in thermal equilibrium. To do this question, you need to know, number one, the meaning of thermal equilibrium. And that, number two, heat energy always travels from a region of higher temperature to a region of lower temperature. Now, since the two objects are at the same temperature, the answer to get the 1 mark here will be there's no net thermal energy transferred between the two objects. Then part B. Figure 3.1 shows the variation with temperature of the densities of mercury and of water between 0 and 100 degrees Celsius. To do this question, you need to know that a physical property that changes with temperature in a certain way can be used to measure temperature. Examples of properties include density of a liquid, which is used in this question, volume of a gas at constant pressure, resistance of a wire, EMF of a thermocouple. We will also discuss the conditions for any of the mentioned properties to be used to measure temperature. So, suggest why for measuring temperature over this temperature range, mercury is a suitable liquid. This question carry 1 mark. 2 points are given here. You just have to state one of the 2 points. Number one is the variation of density with temperature is linear, as you can see from the straight line. Or you can say that each temperature has a unique value of density. Then the second part is water is not a suitable liquid. 2 marks are given for this question, but 3 points are given here. You just have to say 2 of the 3 points. Variation of density with temperature is not linear. As you can see that the graph is not a straight line, but a curve. Different temperature have the same density. The density at T1 is the same as the density at T2 for water. And then region where the density does not vary, does not change linearly with temperature. You can see that the graph is not a straight line. Part C. A beaker contains a liquid of mass 120 grams. The liquid is supplied with thermal energy at the rate of 810 watts. The beaker has a mass of 42 grams and a specific heat capacity of 0.84 joule per gram per Kelvin. The beaker and the liquid are in thermal equilibrium with each other at all times and are insulated from the surrounding. From the passage, we know that 810 joule of energy is transferred to the beaker and the liquid in 1 second. We assume that the beaker provides the heater provides the energy. Second point, the beaker and the liquid are always at the same temperature because the word thermal equilibrium is mentioned here. And then you notice that they also say that the beaker and the liquid are insulated from the surrounding. This means that all the heat energy supplied by the heater is given to the beaker and the liquid. No heat energy is lost from the beaker and the liquid. This figure 3.2 shows how the temperature of the liquid changes with temperature during the heating process. In other words, this is the heating curve. To do this question, you need to understand the heating curve for the liquid. AC represents the part where the temperature is rising, and CD represents the part where the liquid is boiling. For AC, heating causes the temperature of the liquid to rise. The liquid is heated for 21 seconds, as you can see from here. And the temperature of the liquid rises from 25 degrees Celsius to this temperature, which is 80 degrees Celsius. So from here, we can calculate the energy provided by the heater, which is 810 times 21. The heat energy absorbed by the liquid during this part of the process, AC, is equals to MC theta, which will be equals to the mass of the beaker, the mass of the liquid, times the specific heat capacity of the liquid times the temperature change, which is 80 minus 25. Then from C to D, the liquid starts to boil. When boiling occurs, the temperature remains constant, even though heat energy is still being provided. So for part 1, we have to state the boiling temperature of the liquid. Look at the horizontal part, the CD. The answer is 80 degrees Celsius. Then determine the specific heat capacity of the liquid. To do this question, we need to set up the equation. The heat energy provided by the heater is equal to the heat energy absorbed by the beaker plus the heat energy absorbed by the liquid. So this question carries 4 marks. These are the 4 marks. One of the marks is to use Q equals to PT, the energy provided by the heater. Then after that, we will use the formula Q equals to MC times delta T, where M is the mass of the substance, C is the specific heat capacity of the substance, and then your delta T is the temperature change. Then your thermal energy absorbed by the beaker will be equals to the mass of the beaker times the specific heat capacity for the beaker times the temperature change for the beaker. So from here, we can calculate the specific heat capacity of the liquid, which is the heat energy provided by the heater minus the heat energy absorbed by the beaker divided by 120 times 80 minus 25. 120 is the mass of the liquid. 80 minus 25 is the temperature change. This will give you an answer of 2.3 joule per gram per Kelvin. The experiment in C is repeated using water instead of the liquid in C. The mass of the liquid used, the power supplied, and the initial temperature are all unchanged. The specific heat capacity of water is approximately twice that of the liquid in C. The boiling temperature of water is 100 degrees Celsius. So this is the heating curve for water. AB represents the part where the temperature is heated from 25 degrees Celsius because initial temperature is the same to 100 degrees Celsius because the boiling temperature of water is given as 100 degrees Celsius. Then the graph goes horizontal. You have to sketch the variation with time of the temperature of the water between T equals to 0 and T equals to 60. Numerical calculations are not required. So for this question, you have to see the red line in figure 3.2, which is A, B, and then this part here. And this question carries 2 marks. In order to get the 2 marks, you have to sketch a straight line, straight diagonal line from 25 degrees Celsius to 100 degrees Celsius, and then horizontal at 100 degrees Celsius. So this is how it's called the first mark. The second mark is the AB starts from 25 degrees Celsius with a gradient approximately half that of the original. It means the gradient for AB is approximately half the gradient for AC. The reason is given here. The heat energy absorbed during this heating process is equal to Q equals to MC theta. Divide both sides by T. So Q over T equals to MC theta over T. Now Q over T is the power. So equals to MC theta over T. So theta over T equals to P over MC. But it's given to you that the power and the mass of the water is the same as the mass of the liquid. So P and M are constant. Theta over T is the gradient of the line, either AC or AB. So the gradient of the line is inversely proportional to the specific heat capacity, which means that if the specific heat capacity for water is doubled, the gradient will be half. This is why you draw a straight line AB with half the gradient of AC. Facts and concepts you must know to solve this question. Number 1, you need to understand that heat energy is always transferred from a region of higher temperature to a region of lower temperature. Number 2, understand what is thermal equilibrium. Number 3, know that temperature can be measured by using the variation with temperature of the density of a liquid. Number 4, understand and interpret heating and cooling curves of a substance. And then number 5, perform calculations involving specific heat capacity.